more on union, intersection, and the complement of events. So this is a continuation of my discussion on a few of the laws connected with probability. There's a lot of things to talk about probability, but we are talking about only the basics here. So suppose our experiment is rolling a pair of dice, and then we shall take note of the sum of the numbers that appear. So this is the summary of what is taking place in this experiment, okay? So something like this. So the numbers in the first row, these are the numbers in one die. And the numbers here in this column would be the numbers in the second die. And our operation is addition. So the numbers here inside our table would be the sum that appears when we roll a pair of dice. So this is how we interpret it. Let's say, for example, one die shows a 3 and the other die shows a 4. And so their sum is 7. So all in all, we have 36 possible outcomes. Okay, so 36 came from 6 times 6. That is a result of your fundamental counting principle. Okay, so let A be the event that the sum is 8. B is the event when the sum is 10. So let us compute the following probabilities. What is the probability that A or the event is going to be a sum of 8? That is how you interpret it. What is P of A? Okay, so let us interpret A union B. That is the event when either the sum is an 8 or a 10. And what is the probability of that? Okay, so what is the probability that when you roll a pair of dice, the sum is going to be either an 8 or a 10? How about this? How do you interpret that? That is not B. Okay? The event when the sum is not a 10. We will compute for this. What is the probability the sum is not 10? What is the probability that the sum that will appear is neither 8 nor 10? Let us find P of A, the probability that the sum is 8. So it is equal to n of A divided by the size of the sample space. N of A refers to how frequently does 8 appear in your sample space, or in your set of possible outcomes. How often does 8 appear? Okay, so we will just look into this. 8 appears 1, 2, 3, 4, 5. Okay, so the sum of 8 can happen in 5 ways. 6 and 2, 5 and 3, 4 and 4, 3 and 5, 2 and 6. So n of A is 5 divided by n. So P of A, the probability that the sum is 8 in one roll of a pair of dice is equal to 5 over 36. What is the probability the sum is either an 8 or a 10? That is how you interpret A union B. So going back to my slides last time, you compute it in the following way. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So P of A, we already computed for that. That is equal to 5 over 36. How about the probability that the sum is 10? So let us go back to these outcomes, So in how many ways can a 10 appear? 1, 2, 3. It can be when the sum is 6 plus 4, 5 plus 5, or 4 plus 6. So it's going to be 3 over 36. Minus the probability that the sum is both 8 and 10. And of course, you know that that is an impossible event. I mean, the sum cannot be 8 and 10 at the same time. So that is an impossible event, which means the probability of A intersection B is 0. So this is equal to 8 over 36. We cancel common factor. The common factor here is 4. So it becomes 2 over 9. The probability that the sum is either 8 or 10 is equal to 2 over 9. What is the probability that the sum is not a 10? That is how you interpret that. Well, we can do it in two ways. We will count this. Okay, so how many of this? Okay, so there are 33 of them actually, okay? Or we can compute for this probability using our rule for the complement. Okay, so the probability of not B is equal to 1 minus the probability of B. And the probability of B is 3 over 36. So 1 minus 3 over 36, okay? You know, some students really have poor basic math. They wouldn't know how to combine these two fractions. So what I do is I write 1 as 36 divided by 36. So that's just 1. And they have the same denominator. So what I will do is 36 minus 3, that is 33. And then I will just copy the denominator. Again, the common factor is 3. Okay, so we cancel 3 and we are left with 11 over 12. The probability that when you roll a pair of dice, the sum is not a 10 is equal to 11 over 12. How do you interpret this? Not A union B. It is the event when the sum that appears is neither an 8 nor a 10. Okay? And again, we can compute it in two ways. Okay? We can count, okay, the outcomes when, how many outcomes are there when the sum is neither an 8 nor a 10? Okay, so you can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay, so on and so forth. Or you can do it using your probabilities for the complement. It is equal to this. 1 minus the probability of A union B. And we already know the probability of A union B. It is equal to 2 over 9. The probability that the sum is neither an 8 nor a 10 is equal to 1 minus 2 over 9. And that is equal to 7 over 9. Mutually exclusive events. What are mutually exclusive events? Mutually exclusive events, A and B, are events that are observed not to happen simultaneously. So it's like they do not take place at the same time. You do not observe them being together. Okay, so like you and your Mr. Right, okay, or you and your ideal girl, you will never meet each other. You will never occur or meet each other simultaneously. Okay, so you have no Mr. Right and you have no ideal girl. Okay, so when two events are mutually exclusive, it means you will never see them happening at the same time, in which case the probability of A intersection B is equal to 0. And so if we are taking the union, when we are taking the probability of the union of two events and they are mutually exclusive, this means that this addition rule for the union of events will become simply P of A union B is equal to P of A plus P of B, because P of A intersection B is 0. And we saw this from the problem, okay? The event when the sum is 8 and the event when the sum is 10, they cannot happen simultaneously. Okay, it is an impossible event. And so P of A union B here is simply equal to P of A plus P of B, which is equal to 2 over 9.